Hello and welcome to my tutorial on how to do external vehicle aerodynamics using ANSYS Workbench. I'm going to do this tutorial because I've started to do this a couple of months ago for my college thesis paper, and there's a distinct lack of materials to kind of guide very new users in this area. So what I'm going to do is show you kind of how to set everything up step by step, from geometry, meshing, case setup and solution, and then post-processing. I'm going to split this in a couple of videos because I tried to record a full one and it was 80 minutes long before it was over. So first we start with the geometry. For this case I've took kind of a simplified bluff body, and it's called an AMAT body. You can just Google it, and there is really lots of stuff on the internet, because this is the body that's usually used for validation of CFD techniques and software. So I've used the image here from CFD Online, and I've modeled this in SolidWorks because it was kind of the easiest for me. You can also do this in DesignModeler, but I've kind of been more used to SolidWorks. So here's the body. Now it's done according to the technical illustration that I showed you, and the important thing is to pay attention where your coordinate system origin is. So it was at the rear of the body in the road plane, so I've kind of put it in the same place in my modeling. So as we can see, there's the little blue origin. Now the way you can attach geometry into Workbench, there are several ways really, and one of them is to use the SolidWorks direct Workbench connection, and you can do that. You wait a second and it's going to load all the add-ins. I've kind of deselected a few of them on the side here. You can basically turn all of them on if you really think you need it. You can go to View and then Toolbox Customization and just do all, and then you have everything. But I usually do just fluid flow and some static structural cases, so this is more than I need. Now the geometry is attached, but we do need to form the air volume that is going to represent our virtual wind tunnel. So what you do is right click and then just wait and edit geometry. This will open up the DesignModeler, and the way DesignModeler works is you have to kind of finish every command with a generate button. It's here on the top, and it's going to attach the geometry from SolidWorks any second now. Okay, and you can see there's a little yellow lightning bolt here near the attach. So first thing we're going to do is click generate, and DesignModeler will not let you do anything to your model if there is a command pending in this menu on the left. So it's going to go through generating features, and it's going to attach our geometry. Okay, and here it is. You can see there's one part, one body. It's named the same as it was in SolidWorks. Now there's several. This is a full model. This is a solid, and now what we want to do is create a volume of air around it and then subtract this model. But before we do that, I'm going to show you several other ways of attaching geometry. I've also exported the geometry from SolidWorks into a pair solid file and a step file. Now the pair solid file is still a bit more higher quality file than a step file, as you will see. If we go here, you can delete this geometry and just click geometry here on the side. In Workbench you can either double click, or you can left click and drag onto the area here and just let go. So there are several ways of doing that, or you don't really need the geometry tab. Since we're going to do everything in Fluent, we can just create a whole analysis system for fluid flow and name it our AMAT body 25 degrees slant. And then we can right click here on geometry and then import, and we can go to browse, and now we can, let's say, import our parasolid. Okay, it says a little p here, and then again you need to right click and edit geometry. Okay, another generate, and this is much faster already. So you can see it kind of did the same thing as the SolidWorks did, but if we try the same, I mean, well, the part is called a solid and it's not called aim at body 25-degree slant because that kind of information is not carried over in a parasolid file. Another thing we can do is we can create geometry, and then we're going to import. I'm just doing this so I can show you how to merge faces, basically. Import a geometry, and we're going to do it with a step file. Again, right click and edit geometry, or you can double left click. It's kind of the same thing, but I like to use right click. And we're going to do another generate, and now you can see our little legs here are kind of split into two surfaces. Okay, there's not a one cylindrical face, but there are two. So the way you can merge all of these, because later on you have to click each surface and assign a boundary condition inside Fluent, you can go under Tools and Merge. Okay, and then here under Merge Type you will click the down arrow and pick faces, and then we can just pick a bunch of faces. Here is the pick faces selection filter on the top, and we're going to click into this yellow field and then just go and hold the Control key and click all of our surfaces, okay, that we want to merge. Now apply, and it's going to create clusters because it knows these two surfaces are going to be merged together, but it cannot merge these two with the rest, so it creates clusters. Very smart. There's another yellow lightning bolt, and we're going to click generate. Okay, and now this is just one surface that we can select later on in meshing and in Fluent and assign it boundary conditions and inflation layers and stuff like that. The same thing can kind of be done with these surfaces here, for example, but I'm not going to proceed with this because I want to have them separate later on, because we are going to want to have a different inflation layer on this surface than on the straight one. So you can do this and you can generate again. This is kind of useful for more complicated bodies. I will show you my file that I'm doing for college, which is a simplified car model, and then I had kind of a front bumper is made of 10 faces, and then you can merge them all together, and it's kind of useful. But for this one, we don't want this merge, so delete. Okay. Now the way you would like to proceed usually, well, if you have a very dirty geometry, you can go through all of these kind of repairs, and you can repair holes, and you can define what is the minimum hole limit, and you say you wanna delete all the holes on your model which are less than 2 millimeters in diameter, and then you will click this to find faults. Now yes, and it will say no faults found here because there are no holes, but on your geometry it might say 12 holes found, and then it will offer you automatic or manual methods for repair, fill and stuff like that, and you will just click generate. So we're going to delete this.